Hi, I'm Dave Robinson, Chief Data Scientist at DataCamp, and this is going to be another screencast where I analyze data that I've never seen before using R. So, like every week, I'm going to be taking a data set from the Tidy Tuesday. It's a really exciting project from the R for Data Science online learning community, and this week, you discover what data they have for me, where I'm going to analyze it live, recording it all in our studio. So, this week, the data is on malaria. All right, it looks like the source is from ourworldandData.org. And let's find out what we have. A lot of different options, all related to malaria data. All right, it's a challenge from the Malaria Atlas Project Data and Tools. Might still be in the pre-register phase. Okay, and we can access the data to use the mapping tools and access their data set. A lot of it's about mapping. That's exciting. Last week we did some mapping in the U.S. wind data set, so this might be some data that works with more maps. All right. And the alternative is to work with malaria incidence by country for all ages, by country, malaria incidence, malaria deaths, and malaria deaths by age. Okay, so these are two options we have. All right. Let's start, and look, these are each here. I'm going to start by wondering what's the data challenge? All right. Is it released yet is the interesting question to me. Malaria Atlas. Okay, they mentioned the Malaria Atlas R package. Okay, but have they described the? Now I see there's the package. Have they described what the challenge is? What am I going to want to do with that data? Suggestions for the prize: should it generate a new insight tool or health application from the vast amount of data? Okay. I'm going to take a look at this data, and if we feel like it's too much to handle in 1 hour screencast, I'm going to try using this data set of malaria deaths by age or incidence around the world. So I'm gonna start with the Malaria Atlas package. Okay, so I'm gonna create a new RMD as I do when I'm doing a data analysis. Let's find out what we can about the Malaria Atlas package. First, see if can I install Malaria Atlas from CRAN. Looks like I can. Okay. I'm going to load up Tidyverse. I'm going to load up Malaria Atlas. I'm going to find out what's in the package. What can I do with it? So if I take this and I say : I get to find out, aha, so it's going to be all about geography. Okay. Get PR. I wonder what PR means. Okay. Contents, PR locations. I don't know what Plasmodium species. I don't know what PR stands for. I wonder if there's a package level documentation. Here it is. List all, PR points. Yeah, so I don't know what PR points means yet. Okay, I'm going to take a look. Does it share anything about what that means? I'm definitely getting closer to knowing what functions I want to use. PR, parasite rate. Okay, looks like it's parasite rate, that's prevalence of a disease, and clinical incidence rate. Excuse me. Okay. All right, then I think I can use this to make a, all right, then I think I can get some interesting data out of this. Let's find out. If I try get PR or list all, let's start with list all. I thought I loaded the package. All right, I'm not seeing list already. I'll try list data. and I'll try PR points. Okay, looks like the documentation might not be up to date. All right, there's a whole bunch of countries for which the data is available. I'm going to try getting some data. So if I take get PR, that's prevalence rate, parasite rate. Okay, and I can try getting it for a particular country, or I can get it for all of them. Okay, so I'm going to try getting the PR data and see what format that it takes. Actually, I'm going to start just by getting, say, the US. Species needs a country, ISO, name of desired country. So I have to give it the ISO 3 code. So it has to be ISO equals, I believe, USA, if I get it. And if I want species equals both. Okay. I don't know how to get it for the US. Let me see. The US isn't in the data set. Probably doesn't have high rates of malaria. So I could try another country. Let's go with, Okay, let's start at the top. Let's go with Kenya. PR points are available for Kenya. All right, what is the class of this? It's a data frame, a particular type of data frame it looks like. Okay, so I'm going to, each time I download something, I'm probably going to turn it into a table diff first. That'll make it a little easier to print. And I find out a bunch of information. Let's view it. Okay, so this looks like already kind of an interesting data set. We have a site ID and name, longitude, latitude, that we can use that to make a map. We're getting all our data from Kenya right now to start. There's data over time. That's really interesting to know because I might want to arrange that by, let's start with year start. Okay, so PR is at a particular time point. It looks like it might have a start or end, usually equal to each other in this data. But if I try arranging it, I see, okay, we have, some of them can be over a period of time. We have let's see, does anything here more documentation? We have two types of species, a method probably that was used to assess the prevalence, microscopy, or what else? RDT, PCR. I'm familiar with PCR, polymerase chain reaction, from my background in biology. I'm not familiar with RDT. Okay, we have citation. Okay. All right, so I think we're most interested in here, positive, I'm going to guess is out of, is a prevalence out of, it could be out of a million, but it looks like we're always going to number here. This is how, oh no, it's out of this total denominator. The number of, it looks like the number of people examined and the number that were positive, and then the prevalence is the ratio of the positive to examined. Okay, so here's a high, here for example, in this site, Kano Plains, is a high rate of malaria prevalence, 561 people out of 677. Here's a lower one. Okay, so this is giving a sense, this can give us a sense really of malaria prevalence at particular points in space and in time. All right, and this, so it looks like each of these is one study. Column name. This is, yeah, it looks like we don't have too much, we don't really have too much detail in the documentation. Some of it might be a little out of date. But I noticed there's an autoplot method. So if I take autoplot and I graph this, oops, I've already turned it into a tibble diff. I can't, it doesn't like that. I'm going to get it one more time. Oh, right, I need to remove this. We might be able to make an interesting plot right off the bat using this built-in tool. Might be in the operative word. I'm not seeing anything yet. I tried one more time. It took a while. I'm not sure if it if it's not working, or if maybe it's too much data. We have 3,400 points here. We can always graph this ourselves. I just was interested in seeing what they provided. Already I'm thinking about what I'm going to graph. I'm thinking about what's interesting. One is we can summarize right away by year and look over time. Another is we can graph points on a map. We can combine the two and use ggAnimate to graph particular instance points over time. Yeah, it's causing a bit of trouble for me. Okay, I'm probably going to stop this. Nope. I don't see the stop button I'd like to see. Okay. Meantime, we're going to go back to the data. I think I'm going to start with looking at Kenya. I'm sure we're going to look at more countries during this analysis, but I'll start by looking at Kenya. Wow, this is taking a while. The joys of live plotting. Okay. I do sound a little silly. I'm going to open up a new session. Because it doesn't seem to be happy with what it's been, with what's going on in that session. Okay, I do that sometimes to keep myself having some momentum. I hope the other one figures out what it's doing. All right, I'm going to re-download this data. I'm going to call it Kenya. I'm going to quit that one. All right. I'm going to download the data again. Take a look at Kenya, and I'm going to start by, let's count year start. I wonder what years we have in the data. 1985, looks like we have basically every year, looks like, up until about 2015. We don't have the same amount of data from every year. And the important thing to note about this data is that every year only has some number of people examined. Okay. So if I wanted to aggregate the prevalence across time, what I would probably be doing is taking a look at, I'd be grouping by the year. We could start with the year start and summarize the total examined as sum of examined. I'm not an epidemiologist, so they might be used more sophisticated methods. I'm just thinking in terms of totals. The number of people examined and positive each year. And then we can get a prevalence out of that. So I'm also sort of interested in the number of studies that came up with that number. Mostly because notice here we do have 107 people, but they were all from the same city. That is, they were all from the same region, the same study. So I'm not necessarily going to trust that number as much. It's something worth knowing. I'm going to create the PR again right here from positive divided by examined. And now I could graph this over time. So I could say ggplot, I'm going to set my theme. Theme set, theme light. Okay. And I'm going to save this as malaria. Here I'm just still getting a feel for the data set. Seeing what, I'm particularly getting a feel for the data set in Kenya. What has happened to malaria prevalence over time? Certainly looks like good news. For the most part, malaria prevalence has been going down. Okay. We can actually see there are recent years that have only a handful of the studies that they have only a handful of cases. All right, that seems like really good news. Okay. On the other hand, this is not random data, I imagine. I imagine this comes from particular studies, so I imagine there's a lot more care we've got to take with it. All right, let's make a map. Let me see. one of the questions I have is how do I want to visualize it changing over time? Do I want to visualize every study that was performed? I'm interested, are they all over Kenya? Are they all in one area? So I'm going to start just with the all-time data, and we plot as longitude on the x-axis and latitude on the y. I'm going to start with color as year starts so we can get a feel for change over time, and look at geome point. All right, we're missing data for a lot of points on the year start. That's very surprising to me. I could imagine other things being missing, but why would something be missing a time that it happened? Does it have any hints? Okay, it's missing, no permission to release data. Okay, I wonder then, did we get anything out of it? Looks like no. Okay, malaria metrics available, no. The location is available. Okay, in that case, we're probably going to want to filter those out. So I'm going to actually start with filter not is NA. I'm going to start with the PR column, since if that's missing, there's not much we can do with the data. And now we have a graph of, this should be data from Kenya on, okay, and we have a longitude and a latitude. All right, I want to add borders. One thing I can't remember is, am I able to add borders for a particular country? So I'm going to Google this, or I'm going to try searching it. I need to remember what kinds of databases I can get. I know I can get the United States. I did last week, but can I get a particular country? Type package maps. Okay. I've got, let's see, where do I have a country level map? Yeah, most of the maps I'm going to be looking at here have low resolution world map. I think I might be able to pick a region within the world map. I'm not crazy about this because it is low, yeah, as I said, it is relatively low resolution, but I might still be able to get a graph here. Definitely scientists that work with map data more often will probably be able to figure this out. Nope. I thought I could get region out of here. Okay, I'm going to take a quick look at some data. There's map data in the ggplot2 package where I can give it world and find some data from it, which comes in the form of a giant data frame, right? And here's region where I feel like it's going to include individual country names. Canada, Russia, USA. I really expected that Kenya would be on this list and therefore that I could include it in a graph. Yep, there's Kenya. Okay. And what I was curious then is, oh boy, that's embarrassing. I misspelled Kenya. Okay, that was how I got it wrong. All right, so I'm going to fix that. And I'm sure everyone was shouting at me from their computer screens when they're watching this about my mistake, but yes, mistake. All right, so this is a map. Here we have borders of Kenya added to this graph. I'm going to put them under the points. It looks like we have a handful of points that appear to be included outside of what this map considers the borders. All right. One thing we learn is that the studies are definitely concentrated in particular regions. 2 parts of Kenya here in the south, here in the west, and other parts of Kenya are largely missing. These might be where there are cities. I'm not familiar with Kenya geography. Okay. All right, so that's one visualization. One other thing I could do would be to take a particular window of time and try graphing the PR. I can do it overall, where I can just say, where are the high prevalence rates? Whenever I make a graph like this, I usually want to change the scale because you notice that scale of dark blue to light blue doesn't really get across what we'd want with this kind of visualization. Instead, I would usually use a scale gradient. I would say low is blue, high is red. I also need to set the midpoint as 0.5 here. So now we can see some of the areas that have at some point in history had a high prevalence of malaria. Other thing I do while I'm setting the scale color gradient is say labels is percent format. It'll look a little bit clearer. Okay. When you put points on a graph, if you want to show the most dramatic points on top, you want to ensure that you see the highest ones. You can actually arrange them so that in order of PR, it'll actually put the it'll plot the points in the order that they have sorted. So if I arrange them from the lowest PR to the highest, it'll plot the highest ones last. You actually get a somewhat different visualization at that point. All right. And finally, I can throw in a chord map to get the right dimensions. It's been a bit distorted so far. And usually I use theme void in a graph like this. All right, really don't need the scales, the X and the Y. All right, so this is prevalence at any point in time. It's not an amazing graph. I mean, it's because it's flattening all of history. So we'd probably want to do some more aggregation onto it to try and look at a particular point in time. Okay, I've got an idea of how I'm going to do that. My thinking is let's look by decade. Let's have a let's aggregate this by decade first. So if I say here's Kenya PR and I say group by decade equals year start, what I can do is this is dividing by 10 while and then truncating to the nearest integer. So this will say drop it to the nearest 10. So 1989 will become 1980, 92 will become 90. And at that point, I can do my summarize. I'm also going to need to... I'm actually not going to summarize the data. I'm just going to divide it. I'm going to add this mutate by decade, and then I'm going to facet by it. Here it is. So now we can see what studies were performed in each decade and how they differed, and possibly how the prevalence has changed. Okay, one thing this is making me notice is that the same areas tend to be high prevalence over time. You can see this area and this area, both highly, a lot of red, high prevalence of malaria. And what's different in the 2000 decade is they tested a lot of areas that weren't in these really high prevalence regions. So what this is telling me is that earlier graph I made about change over time, this might be confounded by the geographic locations where they were running those studies. That is, they might have had, let's say, for example, more funding in the 2000s to explore other parts of Kenya, they being the scientists that are doing these analyses. And as a result, the fact that prevalence is overall lower doesn't mean it's actually any lower for someone living in a particular point within Kenya. So we found one confounding factor. All right. This is a solid graph. I think I would basically just add a color of a label to the color and possibly a title of something like malaria prevalence in Kenya. And that would be what I'd start with, try and get a feel for the history of prevalence in one particular country. Okay. It's very interesting. We definitely could do this for more countries. I'm making a decision now. We're about halfway through. Okay. I'm going to try a different data set. I'm actually going to take a look at, can I find the Tidy Tuesday? There it is. Okay. I'm going to take a look at the aggregated malaria data. I don't want to dig too deep into a detailed data set, maybe that really deserves a lot more scientific rigor. I'm interested in starting with malaria incidence by country across the world. So we have incidence and we have deaths. I'm going to start with incidence. It's related to what we're looking at right now. All right, so this looks like it's a data set of every 5 years, incidence per 1,000 of the population that's considered at risk. All right, I think it's pretty interesting. And we're going to take a look at the data. Aggregated across countries. I'm going to say malaria incidence is read CSV. And now I have a data set on malaria incidence. All right, I need to rename this data. So I'm going to quickly set names to country, a lot better than entity. Some of it might be regions. I'm not entirely confident. Yep, one of them's world. I'm still going to call it country. Code, year, and incidence. All right, I like that a little bit more. All right, so we can see, for example, that Algeria had a very low incidence. Angola had a very high incidence. This is per 1,000 people, am I right? Okay. I'm interested in actually making those always a percentage. I think it's hard for me to think in terms of out of 1,000. So I'm going to mutate it to divide it by 1,000. So I can say 10% of Afghanistan in this year. Okay. So that's some incidence data. What could I do with it? I could graph it. I could say, let's pick a couple countries. In fact, I'm going to pick countries at random. I'm going to quickly save this as Malaria Inc. processed. My cleaning step. I'm going to take some countries. Filter country in. I like to do this when I'm exploring a data set. I say sample unique country by 6. So that's grabbing 6 random countries, a different random 6 every time. Why am I doing that? So that I can graph the incidence on a single plot. I'm going to say color equals country. So just get a feel for some of the data sets. All right, for example, here, most countries have seen incidence go down over time. Madagascar has seen it spike. I have got this is a percentage, so I'm going to quickly throw the scales percent format. It's going to be a different graph this time. Niger has the highest level. And Mozambique, it's been decreasing. We saw a huge drop in Guinea-Bissau. Okay. All right. So this is understanding some of the trends that we can see. All right. Whenever I have these two sources of data, I'm interested in 2 questions about, let's say I'm interested in 2 questions about malaria incidence. First is what countries have the most malaria. Second is which have been changing the fastest. Okay. So I'm going to go pretty simple. I'm going to say 2000 to 2015. I'm not even going to do a linear regression on this. I'm going to say what has had the, across each country, what countries had the biggest drop, the biggest level to most recently in 2015. So I'm going to call that current. And that's going to be last of incidence. Last is a handy dplyr function that I can just, window function that I can say, oh, I'll need to group by country first. So we can say Afghanistan has it at this current level of 2.3%. Angola has it at the level of 12.4%. The reason I'm noticing that I want to track current is some of these countries have a lot more malaria than others. All right. And finally, I'm going to say change, which is the last of incidence minus the first of incidence. That's going to be change from 2000 at 2015 levels and the change from 2015 to 2000. Other thing is I probably want to do the change as a ratio. Eventually, probably a log ratio. Rather than the absolute value from 2% to 1% is still a kind of a dramatic change. All right, I'm going to start with that. Then I'm going to say, well, instead of mutating, I meant to summarize because I only want one row for every country. Country, current level of malaria, change in the level of malaria. If I'm interested in the countries with the biggest changes, I could do descending change. Venezuela's level of malaria spiked by 2.3 fold. So more than twice as many people have malaria in 2015 and 2000, according to these measurements. Most other countries, it's decreased. All right, that's relevant to know. Which countries has decreased the most? Okay, Argentina. I'm actually, now that I see it this way, I realize I'm kind of interested in knowing every country. Rather than grouping and summarizing, I'm going to try a slightly different approach. Because I'm really interested, like Argentina, okay, it says 0. Did it used to be 0? We might need some smoothing so that we can understand that change relative to other changes. What I'm going to do is say, let's change the year variable. Say it's add a y onto the start of our year variable and spread from the tidyr package, year by incidence. Now we have one row for each year. And now we have current and change here. We have current is just y 2015. And change is y 2015 divided by y 2000. Now ascending arranged by ascending change. Okay. It's really hard to say. This is very strange. Turkey, right here, it suggests it has a incidence above, in the year 2000, above 100%. If I take a look at Turkey's data, I don't really understand how I can have an incidence of 1,741 per 1,000 population at risk. Like, I'm not really, I don't know, I don't know how to interpret that. Okay. It could mean the same person gets malaria multiple times, but that doesn't feel right to me. Okay. I might take a look. I'm not sure what to make of that. But in the meantime, I can say I'm not so sure ratio is the right way to graph this, because I guess I am kind of interested in how dramatic the change is. I'm going to start with the difference. Okay. So this gives a sense of some of the countries. Turkey, again, I'm not sure how it had this high an incidence. All of these incidences feel high. Maybe it's meant to be out of 1 million rather than 1,000, or something else that I'm missing. But yeah, a lot of these are places where malaria has been radically decreased. So I could graph this. I think what I would do would be to say, put on the x-axis the current, the y-axis the change. This is a very popular kind of plot, sometimes called a Blount-Altman plot. And I'm going to filter out Turkey because I'm not sure how to understand it yet. And it's definitely skewing my graph a little bit. One thing we can observe is that you can't drop by a lot unless you have a fairly low current rate. And we have this cluster of countries that have never been that high in malaria. So, okay. So I'm going to add a geom text to the plot where I say label equals. I'm going to start with code because this is a very crowded graph. And if I put full country names, it's going to be even harder to visualize. Some points are missing data. Okay. Worth knowing. We have missing data in the country column. Filter is in a country. Nope. That's not missing anything. I wonder, missing data code. Okay. There are a few points where I can filter those out, where it's grouping together a bunch of areas. So I can filter not is in a code. All right. So we can see only Venezuela has seen an increase in the level of malaria. Some countries like Ethiopia have seen a huge decrease. Okay. If I see data like this, I'm going to want to put it on a graph. I really want to put it on a graph of change in malaria over time. I think that might be, actually I'm going to start with a graph of across countries, across the world of current levels of malaria. When I say current, I really mean 2015. Okay, so I'll take the data and I'll save, I should really have filtered this a little differently. I'm going to save this as malaria spread, like, because we used that tidier spread on the data, and say, there it is, malaria spread, and here's the data. Okay, I want to graph this. To graph it, I'm going to join the data into with its borders. So we saw borders a little bit earlier. In particular, what I did is I did map data world, and we saw this region level data. So we actually saw these names of countries in here. So given that, what I can actually do, I need to join these two data sets together. I could join them on country equals region. It's going to get, I think, pretty close. If not, we can go to the code and go to another data set to join them. But what I'm going to do is say, in this data set, malaria spread, I'm going to anti-join on our map data world. That says, I want to know what data sets, what countries aren't in our map. Country equals region. All right, we have the Ivory Coast, the Congo, and the Democratic Republic of the Congo counted separately. Timor too. Okay. All right, the rest of these are groups of countries, so it makes some sense they wouldn't be in our map. But that's enough for me to say I'd like to get these to match. There's a great trick here. There's a data set in maps called ISO 3166. This actually has the three-letter codes matched up to the names that are used on the maps. So here's where I can say, take our malaria spread data set. So far, so good. Interjoin it with this maps data set by the code. Codes are really, this three-letter code as A3. This code is really handy. It's going to be, it's going to like match across whatever data sets you want to look at, this three-letter code. And as a result, I can use the map name. So now I can select, I'm actually going, when I join it, I'm going to join it only with the A3 and the map name. I don't actually really need any of the other columns. Oops. This data's all over the place. Oops. There. Okay, so now I've got a map name. That means I can interjoin this data set, yet another join, with the borders of the countries. Map data world. Yes, by map name equals region. I did an inner join there. That was a mistake. I really want a left join because I want to keep all of the borders in the world. All right, so this is now, notice what I've got here. I've got Afghanistan. I've got all of its data, and I've got longitudes and latitudes for points that actually draw the borders of Afghanistan. We also have, they can be in groups. We often see multiple islands or multiple areas, and this gives us all the instructions we need to make a graph of the world. So, how would I make it? I'd make it in ggplot. I'd say always longitude on the y-axis, latitude on the, longitude on the x-axis, latitude on the y-axis, and I'd say geom polygon. I need to also throw in group equals group. So to start with, this is less than amazing looking map of the world. I said left join. I really wanted a right join. Good on me. Here it is. This is a map of the world. Anytime I make a map of the world, one of the first things I do is I say filter region is not equal to Antarctica. So I need, I'm going to quickly set this aside. I'm going to say world is this filtered region not equal to Antarctica. Let's find out if I spelled that right. I'm not on a good spelling route today. I just think it doesn't help a graph to have that at the bottom. I'm going to throw in the same things I always throw in to a graph. I'm going to throw in a theme void and a chord map. Okay, we got close to, oh, I think I just stretched it while I was graphing and caused it to, nope. Something's up with this map. If I don't throw in Chord Map, it looks fine. Throw in Chord Map. Oh dear. Okay, I'm not going to do Chord Map today because I don't want to deal with that. The graph's going to look a little distorted relative to how a world map should look, but I don't want to deal with that bug right now. Later, can take a look at what might be wrong there. Okay, so now we have a map of the world. I could fill it a particular way. I could say fill equals blue if we like, but I don't want just a blue map of the world. I want to color it by the incidence of malaria. So I'm going to use fill with one of our data sets. In particular, let's use Y 2015, the 2015 level of malaria within that country. Okay. One of the things we see is that mostly we have data from mostly the southern half of the world. Malaria is a tropical disease, so it's not surprising it's highest around the equator, but we also just don't have people measuring it in the US, in Canada, in Russia, in Europe, in Australia. So we have a choice here. When I did a right join and I left all these in to kind of give a full sense of the map. Having said that, all I need to do is change this to an inner join. And actually now I bet I can put back the Chord map because the bug looked like it was elsewhere in the graph. Sure, okay, great. So this is just me saying, let's focus on the areas where we have data. Let's not even show the rest of the world. It's pretty easy. This is one choice. There certainly are others. We could leave them in, have them white, have them gray, like we just had them. All right. But here we have a graph of malaria prevalence in 2015. I'm going to want to use the same color gradient that I used earlier. I'm going to throw that in. The difference is this is now a scale fill gradient 2 instead of a scale color gradient. Okay? And the midpoint's going to need to be a little different. Usually I use about the median to be the midpoint, so like 0.20. Okay. So now we can see malaria incidence across the world in 2015. And you might remember what I like to do is, we saw earlier this faceting within Kenya. We can apply the exact same graph. We can take, instead of taking the spread data, where we have 2015 as one of the points, we say, look at the process data, look at the incidence, and facet by year. We have 4 points in time, so this is a pretty good graph to look across years. Okay, here's where we get to our really weird point of data with Turkey, which I feel like it has to be bad data. I really don't understand. I don't understand how Turkey could have a level above 1,000 people in this data set. I'm going to actually step in and say include only incidences below 1,000. It also just messes with our color scale. Oops, incidence is below 1 because I've already done the transformation. Okay, so here we're seeing malaria incidence over time since 2000, and generally it does look like good news for the world. Most malaria has always been clustered in Africa, but it looks like it's been getting generally less red. You can see some exceptions. I'm not sure what country this is, but it looks like it went back up in 2010. And yeah, generally we see, this could be a graph we would make out of this data set. We would call it malaria incidence over time around the world, something like that. And we have data from 2000 to 2015. Okay, that's one graph. We could take a look at the deaths data. I bet this is going to be very similar data. All right, this is per 100,000 people. Okay. Ooh, we have a lot more data there. Oh, let's bring it in. We have data for a lot more years. Okay, I'm gonna bring in that data, and I'm actually gonna copy. No one ever tell you. Never let anyone tell you that copy and pasting is something that only beginners do. Copy pasting is great. Malaria deaths over time. If I do it a third time, as the saying goes, I'm going to need to write a function. Malaria deaths. I think it's the same data set, it's called deaths. Okay. And malaria deaths processed. Malaria deaths. Okay, I copy pasted data. I could have joined this. I could have bound the two data sets together to be one after the other. I'm not going to divide by 1,000 this time. I'm going to leave it as out of 100,000. Just having this percentage is not going to be that helpful here. It'll be very low. Okay, so for example, the deaths from malaria had been going up in Afghanistan. I'm actually going to graph deaths across a couple of random countries. I think it's going to be more informative. All right, so I look at malaria deaths processed. Yeah. Okay, so this is more informative because we have data from every year. I like this data set more than the incidence one. I need to drop this off of the scales. And if I were making a graph, I would always say y is deaths per 100,000. Is that 100,000 population or 100,000 vulnerable? Age standardized. I'm not sure what that means. But I'm going to guess it means out of 100,000 people. So we see some countries. This is not a country, this is a category. One thing I'm noticing about this data set is, unlike incidence, I wonder if these came from two different sources. I'm pretty sure this is across the world. I'm pretty sure this one has a lot more data. This has UK, Germany. Those are data sets we did not have in the other I like this data set more. I think we can make more interesting graphs. Yeah, I think I know what I'm going to make out of this. All right. Everybody ready? Because I think we're going to make an animation. All right. It's going to go better than last week. I had a little practice since last week. Not much, but I took a little bit. I'm going to say... Did I copy paste everything? Good. I copy pasted everything. Okay. I'm going to take our world data. I'm going to take the deaths processed. And I'm going to join it with the maps. I join it with maps. I graph it. I can still make this. Ooh, I can't make this graph. I need, instead of incidence, I need deaths. Yeah, I like this data set more. I don't like when I'm looking only at a small subset of countries. I don't like when this is a lot of years. Might be a little bit much for it to graph. How many years are we looking at here? We said 1990 I might kill that. Okay. What I could do is, if I want to make a graph, I could start by saying filter year. I go back to some missing data. Look at start with only every 10 years. This says year mod 10 equals 0. Where's my graph? Can I make any graph right now? Might have broken it. That's okay. I can do the thing that I always do and open a brand new RStudio project. Oh boy. All right. Know what I'm doing now. Tidyverse. Malaria deaths data set. Confirm I can make graphs. I can. Here it is. I'm going to show graphs across the world. How many points is that to graph? A lot. We'll give it a shot anyway. I'm not having luck today with like graphs. Huh. I wonder what I'm missing. Like, this should definitely be a little bit hard, but should not be this hard. Make another graph. Had an unlucky couple of days. I'm going to force quit my other RStudios. Hopefully not force quit this one. Okay. Fingers crossed. Okay, that's not helpful. I'm going to, oh, there it is. I'm getting these faceted graphs. All right. Oh, and I shouldn't have put it on a percent format. All right. So right there, I'd be getting 3 points here. And it's very hard to see the change over time. Okay. I set the midpoint to too high. Or not too high, too low. The midpoint looks like it's going to be 100 deaths out of 100,000. Need to, oops. Oh. Okay, filter. I'm going to start with 1 year. Make it a little bit faster to graph, and then I can start spreading out to a couple of years and doing the faceting. Would you believe it? That old bug is popping up again. I don't like that. All right, I'm going to start here. All right, so this is 1 year. Most countries, especially high-income countries, have no deaths or close to no deaths from malaria. Mostly it's in Africa. This is in the year 2000. I noticed that we're missing China. Let me quickly check whether we're missing it in the data set itself. Country. We are not. I wonder if we're missing it. We aren't. Oh, map name. Okay. Right. I forgot about this. The map name is actually a regular expression. The very strange thing to me that so you can match a couple of expressions. What we actually need to do is use the fuzzy join package. It's confusing to me because this is a problem best solved by fuzzy join, but this data set dates to well before the fuzzy join package was created. So in this field, map name, I have a regular expression. In this one, I have a, in the other one, world, I have the data. So what I actually need to do here is say, I'm going to drop the filter for a moment. I need to change the order in here. I need to say malaria country data is this join with the maps. And then I need to take the world data and load the fuzzy join package and say regex inner join. So this will actually say join when the map data matches this field. So I'm going to flip this around. I'm going to say malaria country data by region equals map name. How does that work out for me? Slow. Oh, yeah, of course it would be slow, wouldn't it? It's got to run a lot of regular expressions. I'm not crazy about this approach in general. Oh, wow. So fuzzy join was one of my packages, which is why you can tell. You can tell because it's very slow and slightly impractical. I didn't put too much work into speeding it up. I'm just so annoyed by all of China missing in this graph. It's not a huge deal, but I don't love it. Oh, I get it. It's gonna, this is not gonna be a Tibble diff, is it? That's part of the problem. If I have to restart RStudio again, oh goodness, I'm gonna be a little bit embarrassed. Terminate R, let's find out if RStudio crashes. Oh dear. Okay, one last try. Okay. grabbing the malaria deaths data. I'm going to do something a little bit silly. What I'm going to do is take this, and I just realized if I say country China, I think I'm going to get most of the way there if all I do is I say filter mutate map name is. This is embarrassing because I created fuzzy join. I should be using it, but I'm going to do a simple hack. I'm going to say replace all times that a parenthesis and then some text appears, replace with nothing. Oops. I actually could use string remove for that. And now I can join. And now if I say country is China, I just get China for the map name. This should be joining together. Okay, so now if instead of a regex inner join, I just do an inner join, this I should feel pretty good about this. Let's see what I got. Okay, so now if I take this, don't need this next line anymore. And I try mapping it. Oh, I forgot to filter for a year. I keep making graphs that have a lot more data than I want to graph them on. Okay, but this should include the entire world. I did an inner join here. Yeah, at least it should include every country that we have data in the malaria data for. And too many facets. Okay. Oh, did I manage to, let's see if I managed to stop that without breaking the graphics device. Okay. I'm going to say filter for year is 2000. Try this one more time. Oh, I need it after the data is joined together. All right, so I got into some details there and got lost a little bit, but mostly what we're interested in is how can I show this evolving over time, this graph of malaria incidence. This is actually malaria deaths over time across the world, and if I say fill is deaths per 100,000. So we see the highest it is across the world in the year 2000 is 200 out of 100,000. That's 2 out of 1,000 people. It's a very, very high rate of death from one disease. All right, so but most of the world we can see malaria generally isn't found. We see it's found more often near the equator. All right, let's take this graph and let's make it an animation. If I say GG animate, right, I want to, and here's our data. I'm going to filter just for, let's start with just 2 years. 2005, let's start with 3 years. It makes for a slightly better looking graph. What I'm going to say is look at 2000, 2005, 2010. I'm going to quickly save this as malaria map data. I've really gotten all over the place in terms of my data processing steps. Okay, country data, map data. All right, now I take this. Right now it's got 3 years of data. I want to add a transition. I want to separate. So I say transition manual year. So I want to say I want 3 different frames. One is going to be 2000, one is going to be 2005, one is going to be 2010. Let's see what we got. Is it changing? It's changing. There it goes. We just need to give it a second. Aha, now we have our 3 data points. Now that I see it's this fast, I think I may be able to run it again. And I'm just going to say every second year, mod 2 is 0. I'm going to graph it only in even years, just while we're still experimenting with this. I wait for GG Animate to work. Okay, so this should be a series of frames, one for each even year while this data has been stored. Aha. Red, red, less red, less red, less red. That's pretty exciting. I'm seeing it changing over time. Okay. I think that at this point I can use transition time from GGAnimate. So I think I can say transition time, which if I remind myself, okay, yeah, I think it will blend those together, and I believe that then I can put frame time into the title. So I can say, in fact, I'm going to try doing it in the subtitle. If that works, that'd be pretty cool. If I say year frame time, I'm going to start with I'm going to go for broke here. I'm actually going to, yeah, I'm going to leave it in the I'm going to put it in the title. I really need to decide that kind of thing ahead of time. All right. So what I'm hoping for here is there's going to be a graph of change over time. Just hit me that interpolating this data might be really, really ugly for GGAnimate. Maybe I should have stuck with transition manual. This is a huge amount of data. It's hundreds of thousands of points. I don't know what to do with this argument. I have no idea what to do with this. It could be a bug in GGAnimate. I'm gonna cut my losses and stick with transition manual. One challenge here is I still haven't figured out how to show in the title the changing year. But I do think it's going to make a pretty solid graph. Still taking a little longer than I expected. Transition manual by year. Okay. There it goes. 15 more seconds and we'll have a cool animation. Still can't use Chord Map. I'm disappointed about that. But let's see. I also realized saying midpoint to 100, it's probably a pretty good place to put it. Watch that. Okay, so malaria went up for a period of time. It's hard to tell if maybe but it's definitely going down. All right, so it goes up in some countries, definitely up, and then back down. Most of the world, it didn't really seem to change, but it definitely went up and then back down there. That's really interesting. I'm going to have one last variation on this graph, and that's where I realized that I'm most interested in Africa here. We can tell most of the world has relatively little malaria and also relatively little change in malaria. So what if I filtered only for countries in Africa? There's a trick to that. There's the country code package. Has the ability to turn a country code or name, but I'm going to go ahead and use that code. It's very into a continent. I believe it's country code, and then I say code, comma, ISO 3C, comma, continent. I'm going to say, oh no, not continent dot name, continent. There it is. Aha. So now I see Afghanistan is in Asia. If I filter only for continent equals Africa, and I change the graph as a result, this might be a more informative graph. We zoom in more in the areas that show the most variability in terms of malaria deaths. Also a little bit faster to graph. It's not graphing all of these countries that generally aren't changing. All right. I think that's a pretty good graph to end on. So I took a look at some of the malaria atlas. To summarize, I took a look at some of the malaria atlas data, particularly some in Kenya. We took a look at particular sites. Decided that we might want to look instead at the aggregated data since we only have a limited amount of time together. But it still is definitely some really great. I think some really important work could be done with this more detailed data set. We looked at the incidence data. We discovered it didn't have a lot of years or a lot of countries, and I decided to fixate on the malaria deaths over time, which we can graph for random countries, or we can look at across time within one. Oops, I don't remember which graph that was, but yeah, we create an animation was, I think, the most relevant one. And I think that was a really exciting way to take a look at this data. And this is a somber data set. It's a data set about death and about some real tragedies, but it's also one that I think is a little inspiring to see progress that has been made in reducing the rate of malaria if we watch these colors change. I think it's one where you can still find some good news for sure. All right. Thank you very much for joining me, and I'll see you next week.